Today's lesson rewind is on lesson 9, direct variation. Some of the main points of what we learned today is how to find the constant of proportionality of a direct variation from a graph or an equation, and how to determine if a situation represents a direct variation. Now, direct variation is going to be really similar to what we've been doing with proportions and slopes and unit rates. So a couple of the vocabulary words are going to be direct variation, constant of variation, and constant of proportionality. So direct variation is a relationship in which the ratio of y to x is a constant k. So we say that y varies directly with x. So if we look at the symbols, we've got y over x because we said it's a ratio of y to x. So we have got y over x is equal to k, which is that constant. Or we could say y is equal to k times x, where k can never be 0. So an example of this is y equals 3x, and 3 is going to be our constant. And then if we look at this graph, we start at the origin, and we go up 2 over 1, up 2 over 1, up 2 over 1. So our slope, or our unit rate, is going to be 2 over 1. And so our slope is that constant 2, so we've got y equals 2x. So for number 1, we have the height of the water as a pool is being filled, is shown in the graph. Determine the rate in inches per minute. So the first thing it says, since the graph of the data forms a line, the rate of change is constant. So the pool is filling at a constant rate. So it says use the graph to find the constant of proportionality. So when they say constant of proportionality, we're just going to find the proportion like we've been doing. So we've got the height over the time. So we go up 2 and we go over 5. And so if we find the unit rate, we have 0.4 over 1. Then we'll go to the next one. We go up to 4 over to 10. So that's 0.4 over 1 if we find that unit rate. And then we go up to 6 over 5 more to 15, which is the same unit rate, 0.4 over 1. And then we go up 8 and over to 20, and we get the unit rate of 0.4 over 1. So the pool fills at a rate of 0.4 inches for every minute. So this is our constant of proportionality. It's our proportion, and it's our slope. These are all different ways to say the same thing. So let's look at number 2. The equation y equals 10x represents the amount of money Julio earns for x hours of work. Identify the constant of proportionality and explain what it represents in this situation. So this is that equation that we were looking at a couple slides back. So we've got y equals 10x, where 10 is going to be our constant k. So the first thing we're looking at is y equals k times x. So we're comparing it to that equation, and k is that constant of proportionality. So our situation is y equals 10x. So k is equal to 10. So the constant of proportionality is 10. So Julio earns $10 for every hour that he works. So when it asks for that constant of proportionality, we're looking for that k value because k is our constant, as we said a couple slides back. So this value, 10, is our constant of proportionality. If we drew a graph, it would be our slope. And we know it's proportional because he makes $10 for every hour. So those are those buzzwords that we've been looking for. Pizzas cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? So we make a table and a graph, and we get, the top is the number of pizzas, and these are our x values. The bottom is cost, and these are our y values. So we plot them on this graph. So we put the number of pizzas over the cost because we have x over y. And we get 11 over 1 because our first point is at 11, 1. And then we get 19 over 2. And that reduces to 9.5 over 1. And so we know we don't have a proportion already because 9.5 over 1 is not equal to 11 over 1. So we don't even have to figure out the rest of these. So there is no constant ratio and the line does not go through the origin. So there is no direct variation. If you don't have a proportion, then you can't have a direct variation. So those are the 3 examples that we went through in class today. Good luck with the homework.